So here is the example 9.1. The objective is to apply the equations for velocity and acceleration for simple harmonic motion. An object executes simple harmonic motion whose displacement x varies with time t according to the relation x is equal to 8 sine 3 pi t, where x is in centimeters and t is in second. So we go one by one the question. So first you have to find the amplitude, frequency and period. So the equation is x equal to 8 sine 3 pi t. So you have to compare with the simple harmonic motion equation, x equals to a sine omega t. So here, okay, the amplitude is 8 centimeter. The omega or the angular frequency is 3 pi. So you can write it here. A is 8 centimeter. So second, you have to find the frequency. So daripada omega equal to 3 pi radian per second. We know that omega equal to 2 pi f equal to 3 pi. So we cancel off pi. We have x equals to 1.5 hertz. Okay, so then you have to find the period. So the period t is equal to 1 over f. 1 over 1.5. So t is 0.667 seconds. Alright, so we go to the second question. We have to find the velocity and acceleration. So to find the velocity and acceleration of any time t, so you have v equal to dx over dt. Alright, so you have a omega cos omega t. So v, a is 8, omega is 3 pi. So you have cos 3 pi t. So then you have 24 pi cos 3 pi t. And then don't forget to write where v is in centimeter per second and t is in seconds. Right, so satu lagi have to find the acceleration. So for the acceleration, a equal to dv over dt. Okay, a equal to negative a omega squared sine omega t. So a negative 8 3 pi squared sine 3 pi t. So here we have negative 72 pi squared sine 3 pi t. Don't forget to write where a is in centimeter per second square and t is in seconds. For question C, you have to find the displacement. Okay, the displacement, the velocity and the acceleration at t equal to 2 seconds. So here you have x is equal to 8 sine 3 pi t. So here 8 equal to 8 sine 3 pi t is 2 seconds. So you just insert in the calculator, but don't forget to change the calculator mode to radian mode. So when you enter the calculator, you have x equal to 0 centimeter. Okay, second we have the velocity. So the velocity is 24 pi cos 3 pi t. So again, okay, you put t equal to 2 seconds. So we have v is equal to 75.4 centimeter per second. And the last one, you have to find the acceleration. For the acceleration, you have negative 72 pi squared sine 3 pi t. So we put the t is 2 seconds. Okay, tekan calculator, then you will have A is 0 centimeter per second square. But don't forget to change the mode to radian mode. Alright, so for D, you have to find the maximum speed and maximum acceleration. So to find the V maximum, we know that V maximum is A omega. So V maximum, A is 8, omega is 3 pi. So tekan calculator, you have 20 per pi. Don't forget to put the unit centimeter per second. Okay, because 8 is in centimeter. So then you have to find the A maximum. A maximum is equal to omega square A. Okay, so A maximum, omega is 3 pi squared 8 centimeter. A maximum is 72 pi squared centimeter per second square. Okay. Example 9.2. The objective is to apply equations for kinetic energy and potential energy for simple harmonic motion. An object of 3 kg executes in linear simple harmonic motion on a smooth horizontal surface at frequency 10 Hz with amplitude 5 seconds. Neglect our resistance, determine the total energy and the potential and kinetic energy where the displacement is 3 centimeters. Okay, so first we have to find the total energy. E is equal to half Ka squared. So E is equal to half. We know that K is m omega squared A squared. Okay, so E equal to half. Mass is 3. Omega is 20 pi squared. Amplitude is 0.05 squared. So the total energy is 14.8 joules. So to find the kinetic energy, okay, to find the kinetic energy, you have to find the potential energy first. Potential energy U is equal to half m omega squared y squared. Okay, so U mass is 3, omega is 20 pi squared, omega is 0.03 squared. So U is 5.33 joules. Okay, so here we have we have the total energy and we have the potential energy. So we know that the total energy E is equal to U plus K. So to find K is equal to E minus U. So K 14.8 minus 5.33. So K we have 9.47 joules. Okay, so now we go to the next slide, example 9.3. You have to discuss the displacement time graph. So the question is shown where here is the sinusoidal graph. So this is 15 centimeter. We call as amplitude. Amplitude is the maximum displacement. So this is the period of the object T, where T is 0.8 second and amplitude is 15 centimeter. So the first question, determine those oscillation, the amplitude, the period and the frequency. So we know that the amplitude is 15 centimeter. Don't forget to write the unit. The period is 0.8 second and the frequency. So we know that the frequency F equal to 1 over P. So we have 1 over 0.8. So we have 1.25 Hz. Okay, so finish A. B, the angular frequency is omega. So for the angular frequency, omega is equal to 2 pi over t, or we can have 2 pi f. Okay, so we know here the omega is 2.5. Okay, you have 2 pi, the frequency is 1.25, so we have 2.5 pi radian per second. Alright, so we go to the next question. The equation of displacement as a function of time. So we know that x is equal to a sine omega t from the graph given. Alright, so x amplitude is 0.15. Okay, ini saya dah tukar kepada meter, tak ada masalah. So sine 2.5 pi t. Okay, so you can write where x is in meters and t in seconds. Okay, so finish. See? Okay, so for D, write the equation for velocity and acceleration as a function of time. As a function of time, ni maksudnya akan ada x in function of time. Sini, v in function of time and a in function of time. So for v, we have dx over dt. So d, you have to differentiate 0.15 sine 2.5 pi t. Okay, so you will have v 0.15, okay, 2.5 pi cos 2.5 pi t. So the velocity is 0.375 pi cos 2.5 pi t. Okay, so for the acceleration, right, so kita ambil ini slide dulu. Alright, so for the acceleration, we have dv over dt. So a d over dt. Okay, v kita dah tahu tadi 0.375 pi cos 2.5 pi t. Okay, so a is 0.375 pi 0.5 pi. Okay, differentiate cos, we have negative sine 2.5 pi t. Okay, so then you will have negative 0.938 pi squared sine 2.5 pi t. Okay. Next is example 9.4. Discuss the acceleration displacement graph. From this graph, we know that the maximum acceleration is 0.8 meter per second square and the amplitude is 4 centimeter. And the mass of the body is 2.5 kilograms. Alright, so determine the amplitude, the period, the maximum speed, and the total energy. This is the question because shows the relationship between the acceleration and its displacement from a fixed point for a body of mass 2.5 kg. Determine the amplitude. So the amplitude is, okay, amplitude is 4 centimeter. 4 centimeter. Okay, so B. So B, macam mana kita nak cari period? Okay, so we can have period from kita punya A maximum. Okay, A maximum equal to 0.80 meter per second square. And then A maximum kita tahu sama dengan A omega square. Okay, and A maximum equal to A omega is 2 pi over T square. Alright, so A maximum is 0.8. The amplitude is 4 times 10 power of negative 2, 2 pi over T squared. So here you can have T, okay, where T is equal to 0.40 second. Okay. Okay, dah finish A, finish B. Okay, kita nak cari pula the maximum speed. Okay, the maximum speed. So, V maximum. So, V maximum is equal to A omega. So, V maximum, A is 4 times 10 power of negative 2. Omega is 2 pi over T. T is 1.4. So, the V maximum is 0.180 meter per second. So, what is C? For D, the question asks to find the total energy. So, total energy E is equal to half KA squared. K ni kita gantikan dengan M omega squared. So, A squared lah. So, E half mass is 2 times 5. Omega is 2 pi over 1.4. And the amplitude is 4 times 10 power of negative 2 squared. So, the total energy will be 4.03 times 10 power of negative 2 joules. Okay. Next is example 9.5. We have to use expression for period of simple harmonic motion for simple pendulum. A simple pendulum has a length of 1.5 meter and the mass of the bob is 10 grams. Calculate the period of the pendulum. So, we use the equation. T is equal to 2 pi third of L over G. So, T 2 pi, the length is 1.5, G is 9.1. So, T is 2.46 seconds. B, if you want the period of the pendulum to be 1 second, calculate the new length of the pendulum. So, T is equal to 2 pi third of L over G. So, we want period is 1 second. So, we analyze the equation. T squared 4 pi squared L over G. So, you have to find L. L equal to T squared G over 4 pi squared. Okay. So, L, T is 1 squared, 9.81 over 4 pi squared. So, L is 0.248 meters. Example 9.6. You have to use expression for the period of simple harmonic motion for the single spring oscillation. A spring is mounted horizontally with its right end held stationary and a mass of 0.4 kg body is attached to the left end. The body is freely oscillating with the period of 0.5 seconds and the maximum displacement is 0.020 meters. Calculate spring constant, angular frequency, equation of motion, velocity and acceleration. For the spring constant, we have T is equal to 2 pi third of M over K. So here you have to find the spring constant. So we analyze the formula for pi squared M over K. So K equal to 4 pi squared M over T. Okay, so we substitute all the given values. So we have K is 63 Newton per meter. And then B for the angular frequency, omega equal to 2 pi over T. Omega 2 pi, T is 0.5. So, omega is 13 radian per second. And then, you have to find the equation of motion of the body. So, the equation, x is equal to a sine omega t. So, x equal to 0.02 sine t in seconds. Okay, for t, the velocity and acceleration when displacement is 0.01 ohm meters. So we use the formula omega a squared minus x squared. Omega is 13. So the amplitude given is 0.02 squared minus 0.05 squared. So the velocity is 0.225 meter per second. So then find the acceleration. Negative omega squared x a equal to negative 13 square x is 0.010. So the acceleration is negative 1.96 meter per second square. This negative just shows that the acceleration is different direction with displacement.
Example 10.1, figure above shows the wave profile at time t equal to 0 second of a sinusoidal wave that travels in a straight line to the right at constant speed 10 meter per second. You need to write wave equation that represents this wave. So, based on the wave profile move to the right, okay, so the equation that you have to write is y equal to a sine omega t minus kx. So you have to fill up a, omega, and k. So to get the frequency, you can use equation v equal to f lambda. F equal to, our v is 10 divided by 1, you will get 10 hertz. And omega, you can simply get from the omega equal to 2 pi f. Omega equal to 2 pi times 10. So then you will get the angular velocity is 20 pi radian per second. And wave number, by using the formula of wave number, k equal to 2 pi over lambda. 2 pi divided by 1, you will get 2 pi radian per meter. Okay, so to fill up this wave equation, you know, the wave equation is y equal to a sine omega t minus kx. We'll just substitute here. Amplitude, we have here 0.2 meters sine omega. Our omega is 20 pi. T minus our k is 2 pi x. Okay, so you have to write also with the sentence where y and x in meter and t in second. Example 10.2, you need to sketch graph y against t and y against x graph. Right, so ocean waves with a crest to crest distance of 4 meters. Okay, this is 4 meters, which can be described by the wave function y in terms of x and t equal to 0.8 sine 2 pi x over 4 minus t over 2, where y is in meters and t in second. You need to use the same axis. You need to sketch y against x graph at t equal to 0 second, and y against x graph for t equal to 0.5 second. However, for question B, you need to sketch y against t graph for a particle of x equal to 2 meters. Regarding to this figure, lambda given is 4 meters and speed is 2 meters per second. Alright, so let us expand the previous equation given in question 10.2, which said that y in terms of x and t, which is equal to 0.8 sine 2 pi times x over 4 minus t over 2. Alright, so let us expand it. So now it becomes as x in terms of x and t, y in terms of x and t equal to 0.8 sine pi over 2x minus pi t. So let us compare with the progressive wave equation, where our progressive wave equation is y in terms of x and t equal to a sine kx minus omega t. So you will have amplitude is 0.8 meters with number pi over 2 radian per meter and omega pi radian per second. So we are still not answer the question. The question said at sketch y against t graph for t equal to 0 second. Okay, so you need to substitute from this equation. Okay, from this equation I choose this upper one equation. So y in terms of x and t equal to 0.8 sine 2 pi times x over 4 minus t over 2. So you will substitute that value. You will get y in terms of x and t equal to 0.8 sine 2 pi times x over 4 minus at t equal to 0. Okay, here at t equal to 0 means 0 over 2. So you will get, okay, you find out the answer x 0, 0.8 sine pi over 2 x. Okay, so once you calculate it, you will get at x equal to 0, right? You substitute here x equal to 0, your y also 0. Once you substitute x here, okay, x here, okay, we substitute x here as a 1, okay, you will get 0.8. Okay, same also, it will showing you the value is in sinusoidal, give you sinusoidal graph. Okay, 0 and here negative 0.8 and at 4 it is 0. Okay, so from the equation, based on the equation which is 0.8 sine pi over 2x, okay, you can sketch a graph which shows that the amplitude is 0.8 meters. Okay, the lowest amplitude is negative 0.8 meters, and you have lambda, okay, lambda 4 meters, and from here you will get, you answer the question A1. Sketch y against x graph at t equal to 0 second. Okay, let us look at for a case t equal to 0.5 second. So we are just substitute the previous equation y in terms of x and t equal to 0.8 sine 2 pi times x over 4 minus t over 2. So you have to substitute this t into 0.5 second. So then you will get a new equation which shows that y in terms of x and 0.5 equal to 0.8 sine 2 pi times x over 4 minus 0.5 over 2. Right? So if you expand this equation, you will get 0.5 second equal to 0.8 sine 2 pi x, 2 pi over 2x, okay, sine pi over 2x minus 0.5 pi. Okay, so what you have to do is when x equal to 0, you substitute this x equal to 0 and you will get the value of y 0 0.0 negative 0.8. Okay, same also if you substitute when x here equal to 1, you will get 0. Okay, so here I can what you call shows you sinusoidal waveform. Okay, 0.8, 0 and negative 0.8. So what you have to do is sketch this y against x graph. Okay, plot a sinusoidal graph. We start at 0, y negative 0.8 and x 0. Okay, which is pointed here, and we just follow from this table. Okay. Okay, you need to sketch y against t graph for a particle at x equal to 2 meters. So regarding to our equation y in terms of x and t, which is equal to 0.8 sine 2 pi times x over 4 minus t over 2. So you have to substitute the value of x. Okay, our x value is 2. Okay, y, x value is 2t, which is equal to 0.8 sine 2 pi times 2 over 4 minus t over 2. Okay, so you need to sketch y against t graph. So your t is based on this table is from x equals, start from x equal to 0 until 1, 2, 3, 4. Okay, so y in terms of 2t, which is equal to 0.8 sine pi minus pi t. So you substitute 0.8 sine pi minus pi over t. Pi, the value of t here is referred to 0, 1, 2, 3, and 4. So once you substitute, you will get your y values 0, 0.8, 0, negative 0.8, because it shows sinusoidal waveform. Okay, and 0. Okay. Alright, based on equation y in terms of 2t equal to 0.8 sine pi minus pi t. So, based on formula, v equal to lambda over t, you can simply get the t, which is t equal to lambda over v. Just now, the lambda already given and the v already given, where the lambda given in the equation is 4 meters and the speed given is 2 meters per second. So then you will get the period as 2 seconds. Okay, so based on this sinusoidal waveform, we can plot a graph y against t, okay, by putting the maximum value 0.8 and minimum value negative 0.8 based on our data, right? So the t now we can put 2, okay, the period is 2. If so, the 2 you should put it here, so divide by 1, 2, 3, 4. Okay, we have 4 quadrant. Okay, it's like 4 quadrant. So you can start with here as a 1, here as a 2, 3, and 4 second. Okay. Okay, let us use the standing wave equation based on example 10.3. Transverse wave travel along stretched string at a speed 80 meters per second and frequency given is 200 Hz. So you need to determine the distance between two consecutive notes and a knot and anti-knot. So let us look at, based on the clues given here, speed and frequency, we can find out the lambda. Since we know the v equal to f lambda, lambda equal to v over f, so 80 divided by 200 Hz, you will get 0.4 meters. So this means that the distance, okay, the lambda, the distance from nodes to nodes, okay, or we can also say crest to crest or trough to trough. So regarding to this figure, okay, you need to find two consecutive nodes. We know the two consecutive nodes, since you know here is node, here is anti-node, here is node, here is anti-node, and here is node. So the distance from nodes to nodes takes half of lambda, right? Half of lambda. So we can put here, which equal to half lambda equal to 1 over 2 times the value of lambda that we get just now is 0.4. So you will get 0.2 meters. However, for the distance between a knot and anti-knot, since you know the distance from knot to anti-knot takes 1 over 4 lambda. Okay, means that the distance is just over here. So you can write down 1 over 4 lambda equal to 1 over 4 times 0.4, which is equal to 0.1 meters. Example 10.4, use the standard wave equation. You have given two progressive waves, y1 and y2, and you need to, question A, write the equation of stationary wave, or known as standing wave produced. And B, you need to find the amplitude and of a particle which is located at x equal to 2.6 meters. C, you have to find the position of nodes and antinodes. And D, you need to calculate the speed of this wave. Okay, let us look solution 10.4. You need to write down the equation for stationary or standing wave equation. Okay, regarding to the equation y equal to 2a cos kx sine omega t, this is a standing wave equation. Okay, so we are just substitute the amplitude given here is 5 cos kx, our k is 2 over 3 pi x sine, and this is our omega, 2 over 5 pi t. So from here you will get our standing wave equation y equal to 10 cos 2 over 3 pi x sine 2 over 5 pi t. Okay, this is our standing wave equation or stationary wave equation. And for question B, you need to find the amplitude of particle. So to find the amplitude of particle, you have to use, if the equation is y equal to 2a cos kx sine omega t, you have to start from 2a cos kx. Okay, this is the amplitude of particle at x equal to 2.6. So you have already the answer from here. Okay, the answer from here. So you will get 10 cos, our k is 2 over 3 pi times 2.6 meters. Okay, then you will get 6.69 meters. Alright, for question C, at nodes. Okay, at nodes, amplitude of, as we all know, at nodes, the amplitude of particle is 0 displacement. So this is nodes. That means 0 displacement. So regarding to amplitude of particle, 2a cos kx equal to 0. Right? So cos kx 0 divided by 2a, you will get also 0. From here, kx equal to shift cos, you'll start with shift cos 0 is equal to pi over 2. And then pi over 2 plus pi, you'll get 3 over 2 pi plus 3 pi over 2 plus pi, you'll get 5 over 2 pi. So from here, we want the value of x, right? So we have to rearrange from this list. So you'll get here for 2 over 3 pi x, 2 over 3 pi x, because this is the value of k, equal to half pi, okay, 3 over 2 pi and 5 over 2 pi. So if you just want to find the value of x, means you need to divide 5 pi over 2 times 3 over 2 pi. Okay, so you will get each is 3 over 4, 9 over 4, and 15 over 4, and so on. So the x value that you will get is 0.75 meters each, 2.25 meters, 3.75 meters. Okay, so this is the amplitude, this is the nodes value, displacement value, once it is at nodes. Alright, for solution at antinodes, you know the amplitude of particle is maximum at antinodes. Look at this standing wave figure. This is our antinodes, means that the maximum displacement. Okay, so from the amplitude of particle, you know the equation is 2a cos kx, which is equal to 2a. This is showing that maximum amplitude. Cos kx, we rearrange this equation, equal to 1, kx equal to, okay, shift cos 1 must be 0, pi plus pi, 2 pi plus pi, you get 3 pi. So then you substitute the value of wave number. Just now you have 2 over 3 pi times our x, 0, pi, 2 pi, and 3 pi. So the value of x, you have to divide 0 divided by 3, 0 times 3 over 2, you will get 0 meters. 2 pi times 3 divided by 2, you'll get 1.5 meters and 3 meters. Right, from our previous equation, we have with number 2 over 3 pi radian per meter, and our angular frequency 2 over 5 pi radian per second. So you need to find the speed of the wave. According to the formula of speed of the wave, where v equal to f lambda, we just substitute the value. F we replace from omega over 2 pi. Okay, it's come up from this equation. Omega is equal to 2 pi f, and our lambda is 2 pi over k. Okay, we take from the equation k equal to 2 pi over lambda. So from here we substitute the value. You will get v equal to omega over k. So the omega and k we have from our question given. So 2 over 5, 2 pi over 5 times 3 over 2 pi. Okay, you get V equal to 0.6 meter per second. So this is the speed of the wave. Example 10.6, you need to solve problems related to the stretch string. A stretch wire of length 80 centimeters and mass 15 gram vibrates transversely. Wave travel along the wire at a speed 220 meters per second. Two antinodes can be found in the stationary wave formed in between the two fixed ends of the wire. So you need to sketch and label the waveform of a stationary wave. And the second question, you need to determine the wavelength of progressive wave which moves along the wire, the frequency of the vibration of the wire, and the tension in the wire. Solution for 10.6. You need to sketch and label the waveform of stationary wave. The truth that given to us is two antinodes can be found in stationary wave formed in between two fixed ends. So you can sketch a graph which showing two stationary two antinodes. Okay, we have here nodes. This one is nodes, antinodes, nodes, antinodes. Okay, and against nodes at two fixed ends. Okay, so this is two fixed ends. So it's proof. Means the lambda here to here will at fixed ends of the wire is 0.8 meters. And you need to determine the wavelength of progressive wave which move along the wire. So from the figure in A, lambda equal to length. So the lambda is equal to 0.8 meters. So easy. The frequency of vibration of the wire, the given is velocity is 220 meters per second, length 0.8 meters, and mass 15 gram. So by applying the formula of speed, V equal to F lambda. So you just rearrange this formula, will become as a V over lambda. So your V now is 220 divided by 0.8 meters. So you will get the frequency 275 Hertz. Right, the tension in the wire based on the formula of mu equal to mass over length. Okay, you need to find mu first. Mu equal to 15 times 10 to the power of -3 divided by 0.8. So then you will get mu 1.88 times 10 to the power of -2 kilogram per meter. By referring the speed of wave along the wire, we have V equal to square root tension over mu. So just rearrange this formula by using the tension or T equal to mu V square. Just rearrange it. So you get mu is 1.88 times 10 to the power of negative 2 times 220 square. So you will get tension 910 Newton. Example 10.7. Air columns for case closed end. A tube 80 cm long is closed at one end. A resonance occurs and the vibrating air column in the tube produces sound of frequency 1134 Hz. The fifth overtone mode is found in the air column. Ignore the end correction. So you need to sketch and label the waveform of the air column. And B, you need to calculate speed of sound in air and the fundamental frequency. You need to sketch and label the waveform of air column for fifth overtone. Means for fifth overtone is equal to 11 of harmonics. Okay, so you have to sketch. Okay, this one is for 1 harmonics. This is the fundamental mode for case air column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Don't forget to draw like this, showing this is our standing wave until 11. Okay, and then you have to write down here. This one is your notes and your notes, antinodes, notes, antinodes, notes, antinodes, notes, antinodes, notes, antinodes, notes, and antinodes. Okay, and from here to here it takes 0.8 meters length. Okay guys, this is the complete figure that you have to sketch for 11th of harmonic. Okay. Okay. B1, you need to calculate the speed of the sound in the air. So from the figure in A just now, we have length equal to 11 over 4 lambda. Because of 11 of harmonics divided by 4 for fundamental mode times lambda is our length. So the wavelength is equal to lambda equal to 4 over 11 length. So the lambda is 4 divided by 11 times the length we have just now is 0.8 meters. So you will get the lambda 0.291 meters. You still not answer the question. Question asks you to find the speed of sound where the V equal to F lambda. The F that we have here is 11,134 times 0.291. So you will get the speed 330 meter per second. Alright, you need to calculate the fundamental frequency or fundamental mode. As we all know, for fifth overtone, okay, you have 11 harmonics. Okay, so n equal to 11, number of harmonics is 11. Regarding to the formula of f equal to nf naught, so f naught equal to frequency divided by n. So the frequency we have is 1134 divided by number of harmonics, which is 11. You will get the fundamental mode 103 Hertz. Example 10.8, a columns for open pipe. A fundamental tone of a sound of tuning fork has a frequency of 500 Hz. So you need to determine the first harmonic. Okay, so n equal to 1 for first harmonic. F equal to nf naught, since you have the n is 1 times our fundamental mode 500, so you will get 500 Hertz. And for a second harmonic, it is also for equation f equal to nf naught, 2 times 500, 2 is referred to the number of harmonics, so you'll get 1000 Hertz. However, for a first overtone, it is equal to second harmonics. So n equal to 2. According to the formula of f equal to nf naught, okay, 2 times 500, you will get 1000 Hertz. However, for a fourth question, the second overtone is equal to number of harmonics 3. So f equal to nf naught, 3 times 500, you will get 1500 Hertz if all the harmonics exist. Example 10.9, Doppler effect for stationary speed of observer. A train moves at constant speed 20 meters per second. This is your V source towards a stationary observer. This is your stationary observer, means that your V observer is 0. Standing on a station platform produces a loud sound signal at frequency 500 Hz, and this is your Fs. Determine the frequency of sound heard by the observer. The question asks you to find the F observer when the train moves, given the sound in air is 340 meters per second. This is your V sound. So, based on our formula of Doppler effect, F observer equal to V plus minus V observer divided by V minus plus V source times Fs. So our V observer now is 0. And how about F observer? The words towards the observer or approaching the observer means that the frequency must be higher. The frequency of observer heard must be higher because of the sound approaching the observer. And if here the F observer higher, the V minus plus V source must be minus, because of we want to increase the F observer. So the new equation you have to write is F observer equal to V over V minus V source times Fs. So our V is 340 divided by 340 minus our V source 20 times frequency. Sound frequency is 500 Hertz. So then you will get 531 Hertz. Next question. Determine the frequency of sound heard by the observer when the train moves away from the observer. Means that the frequency is lower. Okay, so if the frequency is lower here, means your V over V plus V source times Fs. We have to plus for V sound plus V source. Okay, because we want to lowering the observer frequency due to the sound move away from the observer. So you have to use F observer equal to V over V plus V source times Fs. So 340 divided by 340 plus 20 times Fs. So you will get 472 Hertz. Example 10.10 Doppler effect for case stationary speed of source. The whistle from a stationary policeman at junction emits sound of frequency 1000 Hertz. So this is your Fs. If the speed of sound is 330, your V. What is the frequency of sound heard? Means the question asks you to find F observer by a passenger inside a car moving with a speed 20 meter per second. The passenger inside a car with a speed 20 meter per second means that this is the V observer. So, based on the formula of Doppler effect, F observer equal to V plus minus V observer divided by V minus plus V source times Fs. So just now our V source is 0 and our F observer will be increased because of the source is towards the junction. Okay, towards approaching the frequency of sound heard by passenger towards the junctions means the F must be increased. If the frequency of observer increase, here you must put positive. So the new equation you will get is F observer equal to V plus V observer divided by V times Fs. So your V now is 330 plus your V observer is 20 divided by 330 times your sound frequency 1000 Hertz. So then you will get F observer 1060.61 Hertz or 1061 Hertz also. Okay, you can use either. Okay, if the case away from the junction frequency of sound heard by passenger inside the car moving with the speed 20 meters per second away from the junction. Means that the frequency observer will hear must be lower because the source is away from the junction. So, based on this formula, to lowering the frequency, you have to put here minus V observer divided by V times Fs. Okay, so you just write down 330 minus 20 divided by 330 times 1000. So then you will get 939.39 Hertz or 939 Hertz you can write. That's all.